Now let's look at this example here where we have so I have an area here. So this is my area. Call this X, call this Y, call this Z. And let's call the distance from here to here A. And let's call the distance from here to here. Now, in this example here, I have an electric field that is pointing in the Z direction. But my electric field is still pointing in the k hat direction, but this is not. So this is a function and depends on X. Now what this means is that if I look at the electric field here, it's not the same as the electric field there. So for example, when X equals to 0, the electric field is 0. But when X equals to 1 meter, it's not 0, right? So the electric field is not the same at every point in that surface area. So this is an example where the electric field is non-uniform. And so when I calculate the flux, I need to use calculus. So the way I'm going to use calculus is that I'm going to pick a small area here. And calculate the flux through that area. Then integrate to cover the entire surface area. So how do I write this area here? Can someone tell me from calculus what this small area is? After A. In calculus, the length is what? The X, right? But what if you have an area? So an area means that in the X direction, you do the X, in the Y direction, you do the Y, right? So that area is the X dy. So write this as the X dy. Again, the area is always pointing the k hat direction. And so in this case, my electric flux the integral is the now this integral is done over the surface. So S is called the surface area. Now, by substitution, if you substitute everything here, this is going to be 100x dx. Now, this integral, you want to integrate this from 0 to a. And then there's one integral that depends on dy that goes from 0. So you've not seen this before, but this is called a higher dimensional integral. So in Calc 1, you've just seen an integral that you have a function f of x, right? You integrate it. But now you do integral with respect to two quantities. So you're doing an integral in the x direction and an integral in the y direction as well. Now, let's see what this integral gives us. If you integrate 100x, you get 100x squared over 2. So this is just going to be equals to, let's say, $50a squared times b. That's my electric flux. So now, so try this at home. So try the same problem. So try this at home. So what if your electric field vector was equals to 100 x squared y? Something like that. Then in this case, you're going to do so you're going to integrate x squared dx from 0 to a, and then you integrate y dy from 0 to b. All right, so take a look at these. So the reason why I'm doing this is because there is one problem on the web assigned homework where you need to do something like this. So again, the point is that always look at the electric field. If it is non-uniform, you need to take integral. But if the electric field is uniform, then you just do dot product. So you have two equations. When do I use this equation and when do I use this equation? If the problem tells you that the electric field is changing, then you do integrals. If it is not changing, you just do dot product.